We now discuss the solution of a problem from the section Statistics and Probability. And the question is related to the probability of a pair of dice in the given context in the question. This question has appeared in the Joint Entrance Examination Main held on 6th April 2023 in the first shift. The given question is a pair of dice is thrown 5 times. For each throw, a total of 5 is considered a success. If the probability of at least 4 successes is k by 3 power 11, then k is equal to, we are given 4 options. Option 1, 82. Option 2, 123. Option 3, 164. Option 4, 75. So, we are given a pair of dice is thrown 5 times. And for each throw, a total of getting 5, that is the sum of the outcomes on each die is 5, then it is considered to be a success. And you are given the probability of at least 4 successes as k by 3 power 11. You are asked to get the value of k. We now discuss the solution of the problem in detail. The total number of outcomes when you throw a pair of dice is 6 into 6, that is 36. So, if one die is thrown, the outcomes are 6. And the other die, if it is thrown, the outcomes are also 6. But these two, that is this pair of dice, are thrown simultaneously, then an outcome x will appear on the first die, an outcome y appears on the second die, and the choices for x and y are 6. Therefore, the total number of outcomes when a pair of dice is thrown is 6 into 6, that is equal to 36. Agreed. Given for each throw, a total of getting 5 is considered to be success. Now, we consider now how many favorable outcomes will be there. So, how many favorable outcomes are there? That is 1, 4, that is 5, 1 plus 4, 5, 2, 3, 2 plus 3, 5, 3, 2, 3 plus 2, 5, 4, 4, 1, 4 plus 1, 5. These are the only 4 favorable outcomes of getting 5 when a pair of dice is thrown. Agreed. So, the number of favorable outcomes are 4 in number. Now, P, small p, denotes the probability of success, and that is given by the number of favorable outcomes by the total number of outcomes. Favorable outcomes are 4 by total number of outcomes are 36. 4 by 36, that is equal to 1 by 9. And you know Q, the probability of failure is 1 minus P. Why 1 minus P? Because the probability of success P plus the Q, the probability of failure is equal to 1. So Q is equal to 1 minus P, and that is 1 minus 1 by 9 is equal to 8 by 9. Given N is equal to the number of trials is equal to 5. Why this number of trials is 5? Because it is given a pair of dice is thrown 5 times. So number of trials are 5. So N is equal to 5. Given the probability of at least 4 successes is given to be k by 3 to the power of 11. and required to find the value of k. We continue in the next slide. Right. And we are given the probability of getting at least 4 successes to be k by 3 to the power of 11. We are asked to find the value of k. Now, the probability of at least 4 successes is given by capital P. The probability of capital X greater than or equal to 4. Capital X denotes the number of successes. So, we must get at least 4 successes, means X greater than or equal to 4. And that is equal to probability of X is equal to 4 plus the probability of X is equal to 5. And let us recall the binomial distribution, and which says the probability of R successes in n independent trials. What kind of trials these are? These are called Bernoulli trials. Is denoted by the probability of X is equal to R, and is given by probability of X is equal to R is equal to NCR into P to the power of R into Q to the power of N minus R, where you know small p denotes the probability of success, small q denotes the probability of failure, which is given by 1 minus p. Let's get back here. So the probability of X is equal to 4 is, X is equal to 4 means R is 4. R is 4. So N is 5. 5C4 into P to the power of 4 into Q to the power of 5 minus 4. So that's going to 5C4 into P to the power of 4 into Q power 1, because N minus R is 1. And P is equal to X is equal to 5. It will be 5C5 into P power 5 into Q power 5 minus 5, that is 0. Agreed. And that is equal to, substitute the values, 5 into 5C4 is 5C1, that is 5, into P power 4, that is 1 by 9 to the power of 4, Q power 1, that is 1 by 8, 8 by 9, plus 5C5 is 1, P power 5 is 1 by 9 to the power of 5, Q power 0, that is 1. So take the LCM. The LCM is happens to be 9 to the power of 4 here into 9 to the power of 5 here, 9 to the power of 5. 9 to the power of 5 is written as 3 square whole to the power of 5. And the LCM, when you take it, it is 5 8s are 40 plus 1. 41 by 3 power 10. So what is given to us? What is given is probability of at least 4 successes k by 3 to the power, k by 3 power 11. So that is k by 3 power 11 is equal to, which we have calculated, 41 by 3 to the power of 10. So what is the value of k? K is equal to 41 by 3 to the power of 10 multiplied by 3 to the power of 11. Cross multiply. 3 to the power of 10, 3 to the power of 11, 3 times it goes, and that will be the numerator. 3 into 41 will be 123. So the value of k is 123. Let's look at our options. In our options, 123 appears against option 2. Therefore, the answer to this question is option 2. That's the value 123. And it is definitely a moderately difficult question. But it's not very difficult or not difficult. It is moderately. That means, you should remember this binomial distribution. If that is the case, then it will be easier. Anyway, that is the detailed discussion of the solution of the problem from the section probability, which talks about the probability of throwing pair of dice to get a success. For a success, there is a definition what is given in that. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.